Okay, this is your lesson on, let's see, complex numbers in trig form. Write complex numbers in trig form to standard form, kind of the opposite of what you did today in class. Today you did standard form to trig form. And you're going to be able to find the product or the quotient of complex numbers in trig form. That means multiplying and dividing. And then we're going to use DeMoivres Theorem to find powers of complex numbers. That's like multiples of squared or to the third or the fourth or to the 12th power. All right, first let's tackle the trig form to standard form. So here is my 3 cis pi over 3. That's my trig form. It has trig in it, has cosine and sine. We're going to write that in standard form. We're just going to write it so that it's like 3 plus 4i. So first, I'm going to look this up on my unit circle, and I get 1/2 cosine of pi over 3, and sine of pi over 3 is rad 3 over 2. And basically, we're done. All we have to do is distribute that 3, and that's it. Okay, that's not that bad, right? Let's try another one. Looking this up on the unit circle, cosine of 2 pi over 3 is negative 1/2, and the sine of 2 pi over 3 is rad 3 over 2. So distribute the 8, and I get negative 4 plus 4 rad 3i. Okay, don't forget about that I here with the sign. All right, what about this one here? Cosine of 135 degrees is rad 2 over 2, negative rad 2 over 2, and sine is positive rad 2 over 2. Distributing the 6 cancels with the 2's, you get negative 3 rad 2 plus 3 rad 2i. Okay, now let's do the product and quotients. The rule for a product and quotient, if you're going to multiply these two complex numbers in trig form, it's a little easier to write it this way. You're going to multiply the r's, because we're multiplying the z's. Multiply the r's, and you're just going to add the two angles. If this was 45 and this 60, then you're going to have the cis 105. Okay, so that's not that bad. And the quotient, instead of multiplying them, you're going to divide the r's, and then you're going to subtract the thetas. Okay, so if you wrote it all out long form, this looks like this. Some of you like that better. Okay, notice that this is plus and this minus here. This is times and this is divide. So let's try one. Let's do z1 times z2, the product. Okay, so I'm going to multiply the 2 and the 8 and add the two angles. So we're going to have 16 cis, and we're going to add these two. The only way I can add two fractions is to find a common denominator. This will turn into 4 6 plus 11 6. So that'll be 15 6. And this is 16 over here. This reduces by 3. And you get 16 cis 5 pi over 2. And since 5 pi over 2 is out of one full circle, we have to subtract off 2 pi. And if you subtract off 2 pi, it's pi over 2. Then if you take the cosine of pi over 2 and the sine of pi over 2, you get 0. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So that's 1i. Distribute the 16. You get 16 times 0 plus 16 times I, which is 6i. Okay. All right. Let's see. You tried to do this one. You find the product. Okay. Come back and see if you did that right. All right. I'm multiplying. So I'm going to multiply z1 times z2, which will be r1 times r2. So that's 12. I'm going to add these two angles. So that'll be 12. And get a common denominator of 6. So this will be 2 pi over 6 plus 1 pi over 6. That's 3 pi over 6. And that reduces to 1/2. Now the cosine and sine of 1/2 or 1/2 pi is 0 and 1. So that's 12 times 0 plus 12 times I. Okay, now we're going to do a quotient. We're going to divide. So we're going to divide z1 by z2. That's 24 divided by 8. Subtract the 375. I get 225. And then finding that in my unit circle, I negative pi over 2 and negative pi over 2 over 2. Distributing the 3, I get that. Okay, so this will be R1 is 1, R2 is 1. So 1 times 1, and then we're going to subtract the 40 by 10, we get 30. And that's going to be rad 3 over 2 plus 1/2 I. If I ask you to do this problem here, negative 1 plus rad 3i to the 12th power, you could use the product rule that we just did and multiply it all out. Foiling just 2 of these would be bad enough, but if you had FOIL all of these, you may not want to do this. Okay? So in comes DeMoivres Theorem. DeMoivres was a mathematician. He looks kind of like a vampire. He's kind of scary looking. I prefer this picture of him from The Simpsons. Okay, he would take this complex number. He discovered a shortcut for multiplying all that out. He would take the exponent and just put that on the magnitude and then multiply the angle by that exponent. That's it. Quite simple. Okay, here's a short way to writing that. So let's try one. So my exponent is 4. So n is 4. So I'm going to just clean this up a little bit so it's easier to look at. Using DeMoivres theorem, I'm going to take the r, which is 3, take it to the 4th power, multiply the 4 by the 150. Okay? So I have 3 to the 4th power, cis 4 times 150. So that's going to give me 81, cis 600. Well, 600 is too big. It goes all the way around the circle more than once. Let's subtract off 360. And we're going to keep subtracting off 360 until we get something less than 360. Right, make sure it's not negative. And we get 240. So that's the final answer here. But if you want to clean that up and write it in standard form, this is in trig form right now. In standard form, you would find the cosine of 240 and the sine of 240, which is negative 1/2 and negative rad 3 over 2. Distribute the 81. And that's your final answer. All right, I'm going to use DeMoivres theorem to evaluate or simplify this complex number to the 12th power. So we need to write it in trig form first. Okay, so first we're going to do all that stuff that we did today. And we're going to find r, which is 2. And then we're going to do the arctangent, rad 3 over negative 1. That's going to be pi over 3. And that's my reference angle. We have a negative, positive. We're in quadrant 2. So I need to subtract that from pi. So 1 pi is 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. Now that we have my trig form to the 12th power, we can go ahead and use DeMoivres theorem. So we take the 2 to the 12th power, and we take the 12 times my 2 pi over 3. So reducing that, we get 4. 4 times 2 pi is 8 pi. Now this number, I know it looks big. Don't freak out about that. That's fine. 4,096. That's fine. But this is more than 2 pi. And we have to keep subtracting 2 pi until we get less than 2 pi. Or we can subtract it 4 times and get 0 radians. So this would be 4,096 cis 0. Now this would be in trig form. And if we want to write that back into standard form, we take the cosine of 0 and the sine of 0, and cosine of 0 is 1, and sine of 0 is 0. So then we get the imaginary part goes away. We'll get 4,096, or it's 4,096 to the right. Okay, let's see. You tried to do this one, and come back and check your work. Alright, hope you finished it. First, we're going to write this in trig form. So we have to find r. R is going to be rad 2. And then we're going to find my angle, but first finding the reference angle. So the arctangent of 1 is pi over 4. And we're in quadrant 1, so we're okay. It's pi over 4. So my 1 plus I to the 6th power is, in trig form, is rad 2 cis pi over 4 to the 6th power. Now using the DeMoivres theorem, we're going to take the 6, put that on the rad 2, and then 6 times pi over 4. Reduce that and get a 3 and a 2. And then the radicals are 1/2. 1/2 times 6, that's really just a 3. So that'll be 2 to the 3rd power, which is 8, times cosine of 3 pi over 2 and sine of 3 pi over 2. And using my unit circle, I see that cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is -1. Distributing my 8, I get 0 plus -8i, which is -8i. How's that? Okay, one more. Okay, let's see. You work through this one. Alright. Hope you're done. Okay, first, we're going to find the trig form. So, rewriting that in trig form, find the magnitude or the radius r, or absolute value. This one looks a lot like the last one. So we get a negative pi over 4, taking absolute value, it's just pi over 4. In what quadrant am I in? We're going to the left and up in quadrant 2. So we're going to subtract pi over 4, absolute value of pi over 4, from 1 pi, which is 3 pi over 4. Putting that into the 8th power. So now I have square root of 2 to the 8th power. Cis 8 times 3 pi over 4. Reducing that, I get 2. And this is the radicals are 1/2. So 1/2 times 8 is 4. And 6 pi is just going around the circle 3 times, right? Subtract 2 pi, you subtract it 3 times and you get 0. So it's 2 to the 4th power times cis of 0 radians. And cosine of 0 and sine of 0 is 1 and 0. And 2 to the 4th power is 16. Distribute the 16, and I get 16 plus 0i. Okay, so guess that's it. Don't forget to do the Google form.